Right now, 100 trillion life forms have taken up residence on you and inside of you. You are like a planet teeming with life, and it's not pretty. You're being attacked, assaulted by armies of tiny beings that can make your skin crawl.
The question is, why are we still alive?
New science, however, may change the way you look at these invaders. That's because many of these creatures are microbes, and they're essential to keeping you alive.
Our own existence depends on their presence.
How is that possible? Could countless legions truly aid in your survival? Who are these microbes that call your body home? And what secrets can we learn from the creatures inside us? Planet Earth is home to a menagerie of creatures living in every conceivable environment. They herd, flock, school, and blossom in their millions. The Earth teems with life. But get above it, take a satellite view, and life is all but invisible. Same with us. When we see each other, it's the satellite view. But get down on the surface, and it's a whole different world. A world of arid deserts, river valleys, hydrothermal vents, and heaving swamps. This planet is us, and it's seething with life.
The human body is not one simple landscape. It's many, many kinds of landscapes and micro-habitats. And these are some of the most densely populated sites on the entire planet, if you can believe it.
I sometimes imagine if we had eyes that were microscopes and I looked at a person, what would I see? I wouldn't necessarily see a human being the way you might imagine it.
Your body has been invaded by trillions of creatures. They've taken up positions virtually everywhere and outnumber your cells 10 to 1. That means you're not just one thing. You're actually a composite creature, part human and part microbe. Who are these microbes that call your body home? For visible biota, scientists have devised a classification system for creatures that are familiar to us. Among the animal kingdom, there are mammals, like lions and whales. There are birds, slithering reptiles, and a myriad of fish species. Plants have also been subdivided and classified. And so, too, have microbes. Among the microbes, there are countless species of viruses. There are parasites, like flatworms. There are fungi, like molds, yeast, and mushrooms, most noticeable to us when they bear their fruits. All of these microbes exist in the wild, out of sight and often out of mind. But microbes like these have also colonized you, and this is where their story gets a little creepy. It's long been thought that most micro-invaders are inconsequential. They're just along for the ride. They have their agenda, and you have yours. Consider a monstrous critter that's less than pint-sized. Rest your head on your pillow, and you'll join thousands of dust mites that have come to dine on your flesh.
In 5 years, 10% of the weight of pillows is dust mite. In 10 years, a mattress accumulates large amounts of debris, including dust mites and desquams of man and dander from animals and fungi and fungal spores, bacteria, particulates of all types, soil, chemicals that come from the mattress and sheets, as well as secretions and excretions from the body, of which there are numerous types. Feces, for example, urine, semen, tears, salivary secretions, nasal secretions, pus, etc.
Go back to sleep. Flesh-eating mites, like most nighttime intruders, are gross, but they're inconsequential. Given that fact, you might be tempted to dismiss microbes altogether. You could live with them or without them. Such musings, however, could be a very fatal mistake. Consider what might happen if you were microbe-free. That's what scientists did in a simple but ingenious experiment. They raised mice in a germ-free environment. On the outside, the mice appeared to develop normally, but on the inside, it was like Frankenstein's monster. Without microbes, the mice had many deformed and warped organs, and their hearts were abnormally smaller. If mice need microbes for normal organ development, what cryptic powers do these creatures unleash on you? To investigate the secret lives of microbes, scientists around the world are collaborating on an epic endeavor. It's called the Human Microbiome Project, and it's considered the biggest life science project of all time. The goal of the project is to catalog all the microbes that live inside you, to see what they're doing and what impact they have on your health.
The Human Microbiome Project is probably the most exciting thing that's happened in microbiology since Pasteur. It's astonishing to recognize how little we know, how much there is to learn, how quick we can learn it, and the impact it's going to have on human health.
It's going to scrape.
With trillions of microbes inhabiting our bodies, identifying them is no small task. Consider your skin. On the open plains of this seemingly desolate landscape, there are 10,000 critters every square inch. In more tropical and wet environments, like the valleys of your armpit, the population skyrockets. Real estate here, the size of a postage stamp, is home to 15 million micro-inhabitants. That's nothing. Dive into the great cave of the mouth, and the population explodes. Microbes cling to the cliff sides of the cheeks. They take root in the granite towers of the teeth. And they anchor themselves in the rugged marshes of the tongue. Your mouth is saturated with hundreds of millions of living beings.
Now, as you move down through the stomach into the small intestine and ultimately to the large intestine, the colon, the numbers reach their peak. We're now a million-fold higher than we were on the skin or in the mouth.
This is the helicopter view inside the colon. See that white stuff? They are countless beings living off of you. Combine the cities of Tokyo, Los Angeles, New Delhi, and New York, and you still wouldn't approach the scale of life inhabiting here. It's profoundly clear that micro-detectives do have their work cut out for them. But over the years, they have improved their sleuthing techniques to a startling degree. In the past, investigators identified microbes using microscopes. That's straightforward enough. The shape of the microbe, like a fingerprint, could identify a suspect. Later, investigators began growing microbes in the lab. This is called culturing. By watching the microbes live in a virtual cage, they gained a window into their secret world. But despite the power of these techniques, the lives of microbes remained largely hidden. There were two basic problems. First, it's estimated that 99% of the microbes that inhabit our bodies cannot be cultured. We can't grow communities in the lab. And second, what investigators really desired was a way to see how communities of microbes live in the wild, on our bodies. They needed another tool, a break in the case, and they got one. It's called metagenomics. On the surface, metagenomics looks like traditional forensics. Investigators send in exploratory probes. They scrape, slice, and siphon off tiny bits of the human body. Within the samples, they extract genetic blueprints of entire communities. The blueprints are like instructions. They give clues to how the communities are built. They also describe how communities behave, and they suggest how the communities may interact with other communities. Thanks to new high-speed technology, data that would have taken 10 years to compile can now be extracted in one afternoon.
There are going to be new discoveries. We expect to identify organisms that may be important for the maintenance of human health, the prevention of human disease.
The top one you see, that's fecal bacterium.
Among the microbial suspects, viruses, parasites, and fungi, there is one that stands head and shoulders above them all. The most notorious invaders on your body are called bacteria. In fact, they're among the most common organisms on Earth. Bacteria are like the foot soldiers of the microarmy. Each one is a living machine, a powerhouse that takes in food and converts it into energy and waste products. It's able to reproduce, to communicate with others, to move around and find the right habitat, and to wage chemical warfare against you and to protect you. Your body is a planet that's been invaded by a cast of alien creatures too small for you to see. But don't be fooled. They are there, lurking in every conceivable niche. Far more than being just benign, scientists believe this microarmy may be invaluable to your survival, and investigators are plumbing new depths to reveal their secrets. Among the brigade of invaders, perhaps the most important are single-celled creatures known as bacteria. Bacteria are some of the first microbes to invade your body, and their frontal assault began before you took your first breath. Long ago, just like this baby, you were virtually microbe-free, nestled safely in your mother's womb. Your body was more like the moon. Nothing was living on your body yet. But that all changed. As birth begins, chaos ensues, and bacteria start their first wave of invasion.
As a baby is born, it is coated with vaginal secretions. And so any of the bacteria that are present in the vagina will coat the surface of the baby and get into the baby's oropharynx or mouth and begin the process of colonizing that child's gastrointestinal tract.
Among the first to colonize planet human are armies of lactobacilli. Like special forces units, they take up position in the baby's mouth and skin. As they multiply, they wage chemical warfare, spraying hydrogen peroxide and acid. This is an offensive maneuver. Its purpose is to kill dangerous microbes that threaten their new home. And many microbes, both friend and foe, are on their way. As the infant begins to nurse, it opens a floodgate to new settlers. Within this river of milk, there are massive swarms of creatures seeking a foothold. Every swallow carries about 1 million colonists. One of the species is known as bifidobacteria, or bifido for short. The bifido careen down the baby's throat into the stomach. From here, bifidos surge forward to the small intestine, where many will hunker down. Those bifido that continue will take up permanent positions at the end of the digestive system known as the colon. Once in place, bifido, among other colonists, play a big role in keeping the baby nourished.
Clearly, the baby's inoculated as the mother's exerting herself, giving birth. That little gift that mom gives you with your first breath is part of what becomes your normal microbiota and helps you start to digest her milk.
By the end of an infant's first day, it will be home to about 100 million colonial bacteria.
Streptococcus mutans,
Helicobacter pylori,
Bacteroides theta iota omicron,
Escherichia coli,
Methanobrevibacter smithii,
Streptococcus gordonii.
As countless species of bacteria fan out and take up positions, they're also doing something that you might find hard to believe. These single-celled creatures are setting up a communication network. And this network was critical to your early survival. Take a step back from the micro world, and it's no surprise that animals communicate. Elephants utilize up to 70 vocal calls, some of which are beyond our ability to hear, In dazzling displays, cuttlefish and squid change the color of their skin, flashing messages, warnings, and signals for mates. Bees dance to direct other bees to nectar. Male and female birds sing duets. Some primates have even been taught to use sign language. But microbe communication? What can microbes do? Investigators studying bacteria have decoded that each species of bacteria has its own unique chemical language. All bifido speak bifido and can communicate with each other. But bacteria also speak a universal code, one that transcends species and lets them crosstalk. Bacteria, it turns out, are bilingual. But what are they saying? Among other things, investigators have deciphered that bacteria started a conversation with your young immune system. Your immune system got a needed crash course on basic defense. With the aid of bacteria, it was prepared for battle.
So the body's always sampling what bacteria are going by, whether it's through the respiratory tract or in the mouth or through the digestive system. And one of the ways it does that, there's these amazing immune cells called dendritic cells, and they reach out little microscopic arms between the cells that make up our mucous membrane, and they sample the bacteria going by, kind of a handshake.
A baby seems to almost be trying to inoculate itself. You know, it's sticking its fingers in its mother's mouth and hastening that day when all the right bacteria are in place.
One of these right bacteria is Streptococcus salivarius. This hardy recruit uses chemical adhesives to hook onto the rough surface of the tongue. Remember, you had no teeth yet to break down food, so Salivarius did it for you. It survives off saliva and bits of food that it helps break down. Among the duties that bacteria provide, arguably the most important is digestion. From birth through adolescence, middle age, to your last meal, bacteria are helping you to make the most of the food that you eat. Among the legion of invaders, bacteria are perhaps the most crucial for your survival, and they undertake some of their most important missions in one of the harshest environments on planet human. This is not a nice place. There are eruptions, active hydrothermal vents, and geysers of hydrochloric acid, which can burn bare skin. It's hot, foul, and hellish, but it's the perfect outpost for bacteria. This is part of your digestive system. Internally, your digestive system starts with the stomach and ends some 30 feet away in your colon. At the top, right after the stomach, is something called the duodenum, a spot in the small intestine where most digestion takes place. Food moves through your duodenum, the small intestine, then the large intestine, and ultimately to the colon. Within this short span, there exists a mind-boggling amount of life.
There are more germs in the intestinal tract of the average man than there are or were men that ever walked the face of the earth since the beginning of time.
In fact, the density of microbes found in the human colon is the highest concentration of microbes of any ecosystem known on planet Earth.
That's not just inside you. That's anywhere on planet Earth. Think about that. You are a whole world unto yourself. There's so much bacteria in your colon that it weighs in at a whopping 2 pounds. Among the creatures that live within the slime there are both heroes and villains. First, the good guys. You've probably heard that the secret to good health is exercise and diet. But you've probably never considered adding bacteria to that list, and you should. That's because bacteria in your gut are responsible for extracting energy from food we can't fully digest. Within your gut, you lack the chemical machinery to fully digest plants, vegetables, fruits, whole grains, and nuts, as well as complex sugars. Bacteria, however, produce organic compounds called enzymes that break up this food into bite-sized pieces that your bodies can use. Simply put, without bacteria, you'd be missing out on a lot of fuel.
The microbes in our gut are responsible for processing roughly 30% of all the calories we eat. We think about termites who eat wood but can't really digest it. In some sense, we're large termites because much of the food we take in can only be digested with the help of these microbes.
These communities make vitamins, make essential amino acids. They're really unbelievably adept chemists.
The process of digestion actually begins here, inside your mouth. Within this cavern, there are legions of hungry bacteria waiting for a meal. A recent census detected more than 19,000 different species or strains among our teeth, cheeks, and tongue.
And the organisms on the tongue are different from the ones that are on the teeth and are different from the ones that are on the cheeks. Each little niche in the body has its own ecosystem with organisms that allow that area to function properly.
In addition to helping with your digestion, bacteria in the mouth also protect you. Their tactic is simple. They occupy every available piece of real estate, leaving virtually no room for hostile invaders.
First and foremost, the bacteria that colonize all the niches just by physical colonization and covering of those receptors form a coating that prevents what are called exogenous bacteria that are not part of the human body.
Mouth bacteria obviously have their good side, but they also have one that's less savory. When mouth bacteria devour leftover food between your teeth, they release acid that can create cavities. Bacteria also excrete the remains of their meals, and it doesn't smell good. We call it bad breath. Perhaps what's even more troubling is that when bacteria escape the mouth and get into the bloodstream, bad things can happen.
They don't really go bad. They're just in the place where they shouldn't be. And once they're in a community or in an area where they are not supposed to be, they can cause an infection.
Colonies of bacteria stay largely to themselves, not much mingling. But sometimes they can combine their forces and unite to create complex living structures, micrometropolises called biofilms. In your mouth, biofilms coat your teeth with elaborate villages we call plaque.
A biofilm can also be looked at as a city of slime, in which there's apartment complexes and towers in which bacteria are embedded into a matrix. And there's channels formed between them to maintain the food and proper transfer of nutrients between different areas and different towers. Some areas of the biofilm are producing products that another area of the biofilm is actually using.
You can help keep biofilms in check with mouthwash, but daily cleaning will do little to control one mysterious invader who enters through your mouth and claims territory in your gut. Meet Helicobacter pylori.
Helicobacter, though it lives in the stomach, really doesn't like acid. So as soon as it gets in the lumen of the stomach, it wants to get out of that really acidic luminal part, and so it does that by swimming.
Helicobacter is tough, aggressive, and can be quick to set up camp. First, it drills through the mucous membrane of your stomach and into the lining. Firmly anchored, it soaks up waste from your cells. Next, it shields itself from your stomach's acid by releasing a cocoon of carbon dioxide and ammonia. Helicobacter can be an obnoxious tenant. That's because it can slowly destroy your cells. This massive annihilation can lead to stomach ulcers and even stomach cancer.
Stomach cancer is a very important disease. It's the #2 cause of cancer death in the world, right after lung cancer.
The link between Helicobacter and stomach cancer is well accepted, but there's a few strange twists to this story. First, Helicobacter is mysteriously vanishing.
Helicobacter is going away very rapidly. Early in the 20th century, we have evidence that 80 to 100% of people had Helicobacter. And now if we look at the latest national surveys in the United States, Of children born in the 1990s, only 5% of them have Helicobacter. So this is a huge decrease, tremendous decrease.
As Helicobacter disappears, the rates of stomach cancer have dropped dramatically, which sounds like a good thing. But just as Helicobacter vanishes, other cancers, like cancer of the esophagus, are on the rise.
Gastric cancer is disappearing. That's correct. The rates of those are going down. But at the same time, new diseases have been appearing. Most importantly, diseases of the esophagus that include a new form of cancer called adenocarcinoma of the esophagus. These diseases are increasing dramatically.
Coincidence? Investigators don't think so. There's strong evidence that suggests that as Helicobacter disappears, there are changes in the stomach's acid that may contribute to the rise of other diseases. As investigators continue to probe the lives of microbes, they may have recently uncovered one of their greatest secrets, a powerful force they exert on planet human. Your body is literally swarming with microbes, both inside and out. They protect you from enemy invaders. They help to keep you well fed. But in their wake, microbes can leave unpleasant side effects, like tooth decay and bad breath. Recent research has also suggested that colonies of bacteria may be linked to an even graver threat: cancer. Everywhere that scientists probe on planet human, new species of life are being discovered, and new powers are being revealed.
We calculate that there are 1 million bacteria per square centimeter of your skin. So, something that big has 1 million bacteria living in and on it.
Just in a small area of the forearm or the skin, we were able to identify 182 species. And when we increased our number of subjects, we found that we were up to about 400 species. It's about the size of an average zoo.
Your skin is home to hundreds of friendly bacterial species. Together, they form a highly effective barrier against enemy combatants.
The healthy bacteria are coating the skin, and they're basically standing on the skin saying, I'm here. This is a really crowded place. Don't even think about trying to move in and live here, because I'm here and I'm eating all the food that's here, so there's not going to be anything for you to eat if you come here.
One of the more populous beneficial skin bacteria is Staphylococcus epidermidis, which coats the surface of the skin. And one of the invasive bacteria that Staph epidermidis crowds out is its killer cousin, which can cause diseases ranging from pneumonia to meningitis.
This nasty fellow is Staphylococcus aureus, Staph aureus. About 20% of the U.S. population are normal carriers. It is a very serious infection when you acquire it in a hospital, because the organism is resistant to many kinds of antibiotics.
Our immune systems would have trouble protecting us from Staph aureus without all our bacterial partners. We need them all over us, all the time. Which begs the question, why should we ever bother to wash?
We shower or we wash our hands with soap and water. We're removing probably about 1% of the bacteria. But what's important is that these are just superficially attached to the skin surface and could be pathogenic. So it is important to wash your hands and wash your body. Your healthy bacteria have a solid ecosystem, and they can repopulate and bring back that 1% that you've lost.
Since your skin is packed with bacteria, you might think it's a hospitable environment. Think again. This world can be unforgiving and treacherous. Just as a microbe takes hold on a skin flake, the flake tears free, taking the microbe with it. For those microbes not shed, they face a nasty brew of chemicals.
Very, very few can withstand that very low pH, and even if they could withstand that low pH, very few can actually grow on the fatty acids that are produced. Also, the skin produces a wide range of antimicrobial peptides.
Peptides are like microbe poison, killing or disabling bacteria indiscriminately. In addition to bacteria, your skin is home to a host of other creatures. The more humid regions of the skin attract various species of fungus, like this itchy patch of ringworm. Among the scrubby thickets that grow along the steep slope of your forehead, there lives another creature that feeds on discarded skin cells, and it's known as
the Demodex mite. That is the follicular mite that you find here at the bridge of the nose, on the eyebrows, in the forehead, and other areas of the body. Elongated mites that go into the follicle.
On top of your head, within the forest of your hair, another colony of microbes eats the fatty oils of the scalp. Its name is Malassezia fervor, and sometimes it overstimulates normal skin shedding. The result? Dandruff. Microbes don't just live on and in your body. They also hatch dubious plans that can lead to trouble. This is a story of infection that begins here, inside your nose. To a microbe, it's a rugged, wet, slippery, and treacherous canyon. Hurricane-like winds in the form of inhalation move through here almost continuously, and the air is full of some infectious agents.
90% of infections begin at a mucous membrane site. For example, the nose, the oral cavity, the lungs, the intestinal tract. That mucus is actually the first line of defense. And then you have cilia that move and sweep these materials that are trapped on the mucus, sweep it down into the gut so you can swallow it and eliminate it.
Your defenses don't always work. That's because they can be overrun by an onslaught of attackers.
When a normal, healthy person becomes ill, it usually is because they were exposed to a very high inoculum. And what I mean by that is a large dose of incoming bad bacteria.
Sometimes, low numbers of bad bacteria are in there, lurking among the good guys. Not enough to create a problem, but they're waiting for just the right moment to strike. Today, Streptococcus pneumoniae is lying in wait. Before they spring into action, the pneumoniae cells are taking a head count, ensuring that they have enough troops.
How does a bacterium know when there's enough of its buddies around? There's a wonderful phenomenon that's being studied called quorum sensing, which allows bacteria to emit a little chemical that says, I'm here. And it's like speaking into an echo chamber. If you don't hear it come back, there's not enough of you around. But if, as the numbers grow, every bacterium emits a little I'm here signal, eventually that will bounce back just because of the crowding and just because of the numbers. And as soon as that signal is re-received by the bacteria, that's the go-ahead sign to start making these virulence genes. And at that point, the infection might take.
Confident in the size of its force, the pneumoniae bacteria begin their assault. They multiply, deploy throughout your body, and unleash their toxins. Now, it's a battle between your run-down immune system and a very tough infection. The invaders have already moved down your throat and into your lungs. Your immune system sends in special white blood cells, which start to devour the bugs like a pack of wild dogs. These white neutrophils also put the whole immune system on red alert. While many infections can be easily treated with drugs, bacteria may cause more insidious problems that are harder to tackle and threaten your life. Throughout your body, microbes often battle for supremacy, and sometimes they can make you sick. But they may also affect your health in far less obvious ways. Obesity has been declared an epidemic in the United States. More than 30% of adults and 16% of children are obese. Since 1980, obesity rates have risen dramatically. For children, they've actually tripled. And all this extra weight has come with a hefty price. In addition to medical costs, obesity poses real health risks, from coronary heart disease and stroke to type 2 diabetes and cancer. A bad diet and lack of exercise have long been viewed as a major source of obesity. And now scientists may have discovered yet another factor: microbes. Bacteria in your gut process roughly 30% of all the calories that you consume. They do this in part by extracting energy from foods such as fruits, vegetables, and grains that would otherwise not be used. Most of us host very similar colonies of gut bacteria. But for some of us, there are significant differences. Investigators suspect that some people possess bacteria that act as if they're on steroids. And these bacteria have the ability to extract heaping quantities of fuel from food. That sounds like a good thing, especially when food is scarce.
Think of two individuals. One individual who has a complement of bacteria in their gut that allows them to harvest 10% more calories from any given meal, and another individual that doesn't have that community. In times of famine, that person who had the beneficial microbes in their gut that allowed them to harvest more calories is more likely to survive.
But what happens when food is plentiful? That's a question that has intrigued researchers. Could hyper-efficient bacteria contribute to obesity? In theory, it makes sense. Jacked up colonies extract more calories. More calories can lead to more fat, but could it be true? In the lab, investigators turned to two groups of mice, one fat, one lean.
Studies have shown that the bacteria in obese animals actually can cause obesity. If you take bacteria from an obese animal and you transplant it to a regular animal, that animal will actually become fatter.
These new findings suggest that if you were to take 5 people, each of whom eat the same exact diet, they will break down that food and put on fat to differing degrees based on 2 factors. One is who they are genetically, and the second is who they are microbiologically.
Given current research, you might think that one way to fight obesity would be to eliminate colonies of so-called bad bacteria. Researchers, however, would urge caution. There's much we don't know yet about how bacterial colonies interact. By killing bad bacteria, we might set off a dangerous chain reaction. There are also other complications. We don't necessarily have the drugs to target specific colonies. Antibiotics, our most lethal weapon against bacteria, aren't laser-guided missiles. They're more like cluster bombs.
For example, if you had a cut in your foot, you treat yourself with an antibiotic that floods your whole body with the antibiotic, and you're affecting the organisms in your oral cavity, in your nose, in your intestine to kill an organism that is causing an infection in your foot.
Right now, we're using clubs and cannons for what should have been an effort made with tweezers and much more precise, targeted therapeutics.
Antibiotics clear-cut through entire ecosystems of bad and good bacteria, making room for new colonizers. Over decades of use, antibiotics have greatly affected the biota of planet human.
Whenever we have an antibiotic for an infection, we are killing some of the microbes we've evolved with. And probably over the last 50 years, we've changed dramatically the symbiotic relationships between us and our microorganisms simply because we've selected a lot of them out of the population.
Many researchers suspect that wide-scale bacterial changes in your body may not be a good thing. They point to the rise in childhood asthma and type 1 diabetes as possible consequences.
As soon as you perturb one component of an ecosystem, you don't know what consequences there's going to be.
Using antibiotics against microbes is a double-edged sword. They can alter the composition of microbial colonies in your body. They can help to create harmful superbugs that are dangerous and even harder to kill. But antibiotics can also save your life. Many researchers believe that in the future, rather than battle microbes, we may find new ways to work with them. But first, we need to learn more about their cryptic lives.
As these methods for fingerprinting microbial communities become easier to do and more commonly done, it may be part of a normal checkup and you have your bacteria profile checked on.
Just going over your hip.
And our 21st century medicine cabinet, when we open it up, may have microbes in it.
Today, one way to support your beneficial microbes is to feed them what they like, to nurture them, the way you might nurture your pets. You can be prebiotic and eat foods that encourage certain preferred species, or probiotic, which means eating the bacteria itself,
prunes and apricot,
as when you eat yogurt with live cultures.
When we think of food, often what we think about is just sort of the main fuel source to our bodies. And I think we have to take this in the context of not only fuel for the humans, but fuel for the bacteria. Probably the best recommendation from the standpoint of maintaining a healthy bacterial community is really eating a diet high in intact plant foods. What you're wanting to do is to allow as much food to get down to the bacteria.
Billions of years ago, when the Earth was very young, long before humans, there were microbes.
Bacteria have been on Earth for 3.6 billion years or something like that, plus or minus 0.2 billion. And they're scrappy survivors. They grow on glaciers, they are what carve out caves, they grow in amazing places. And when they evolved on Earth, the Earth was anything but stable. If they don't adapt and survive, they're dead. So they have an exquisite capacity for sensing their environment, adapting and adjusting.
As the Earth changed, microbes evolved, taking up residence on all living creatures, including the first humans. Throughout our evolution, microbes changed with us, protecting us, helping our species to grow and survive. Science has given us a window into the microbial world, and what we first saw was alarming. But that perception has dramatically changed.
In the past, we looked at microbes as an enemy. Let us defeat them all. Well, we cannot even defeat them all if we tried, but that was our mentality.
The new view would say, number one, the diversity within and on us is far greater than we had thought. Number two, that the interactions are far more complex. It's not just that they are there and along for the ride, it's that they are there to help us be who we are, and we, in turn, behave in a way that supports their own place on the planet, which is in and within us.